Hello, everyone. Welcome back to Code Y, and we are back at it with another HackerRank question. So today's question is quite interesting. So basically, I'll just give a quick, I'll condense the question quickly. So there are three stacks of cylinders where each cylinder has the same diameter. Okay, that doesn't matter, but it may vary in height, and you can change the height by removing and discarding its topmost cylinder any number of times. Find the maximum possible height of the stack such that all stacks are exactly the same height. This means you must remove 0 or more cylinders from the top, etc., etc., etc. Okay, so this question is called equal stacks, where each stack is arranged like this. And what happens is you can pop out the items in the top. So for some reason, they consider the top to be this, to be the top, like this is a better visualization of the question. So over here, they have 3, 2, 1, 1, 1, which means 3 is the topmost, 2, then 1, 1, 1 is the 1 is the bottom. Likewise, over here, 4, 3, 2, and 1, 1, 4, 1. So in this question, what they're saying is we need to pop out as many items as possible from the top to the point where all of them are equal and they must all have the same height. So in this question, the only place where they all have the same height is when 3, 4, 1, 1, 1. These section, these few gets popped out. Like when these are removed, then all of them are the same height. So this question is not a very tricky one, but the main concept is we need to find an efficient algorithm such that we can find out this height as soon as possible. So a few tricks in this question is we need to be very mindful of the time complexity because the numbers that they've given us is quite big, like 10 to the power of 5. And we can, that means each row, like each, sorry, not row, each cylinder, like each text in the cylinder stack might contain this number of stacks, which is just insane number. So if we have multiply this by 3, we have like a insanely huge number. So time efficiency is the goal of this question. Now, to approach this, my strategy is going to be basically, I'll be looking through all of them and I'll pop the largest item because the largest item has to be brought down somehow. Like over here, this is the tallest one. So I need to pop out the first item from the top. The thing that you must notice, we can only take from the top. You cannot take from the bottom. So what I know from this question is I'll scan through all of them. I'll find the tallest one and I'll just remove the item on the top. Now I'll scan again. The highest item is this. I'll remove this. Then I'll scan again. This will be the tallest one. Remove the one. Scan again. This will still be the tallest one. I remove this. And that way I get all 3 of these cylinders to be of equal height. So that is my strategy. And now I'll just jump straight into coding it out. The thing that the reason why I keep emphasizing the time efficiency is very important in this question is because there are a few tricks that you can do. So the first thing that I need to do is I'm going to operate on a while loop basis. Okay, just to check what is the input. Let's just print out and see what is inside H1, H2, and H3. Let's just run this just to see what's inside, what format. So yeah, there are 3 arrays. So what I need to do is I'm going to create a while loop that will check if all 3 of them are equal first. So how do I check if all 3 of them are equal? I need to do something like this. While H1 is not equal to H2, or H2 is not equal to H3. The reason why I need to do not equals to is because I'm going to do my operations below. And when H1, H2, and H3 are all equal, this condition will fail because H1 will be equal to H2. Hence, this will be false. And H2 and H3, if they're equal, this will be false. And only then will an OR condition make sure that this while loop condition terminates and gets to the next line. So we essentially want some code in the below and the bottom over here to perform something such that H1, H2, and H3 are all equal. And once they're equal, it'll terminate the program and go to the next line. So that's the idea that I want. So it's important to note that if it is false or true, you will get a true. The while loop condition still persists and it will still run the algorithm. So if we're using an OR, we need both sides to be false in order to terminate the program. So this is something that you guys can take note of. I don't know where else you would use it, but this is something that you need to know. Like there's a difference between using OR and using AND. So yeah, that is a very important tool to use, I guess. Next thing that I want to do is I want to keep a summation of all of them because I don't want to keep summing them up at every instance in the while loop. I just want to sum them up at first, and then I'll just keep removing them one by one. So to do that, I'll create some ones, some two, some three, and let's just do a summing operation at the start, right at the start. Sum H2, sum 3, sorry, H3. So these, while each summing operation operates at a O(n) time complexity, we will only be running this once. That means if we have 10 to the power of 5 number of items in each cylinder, we will only be summing them once, and we have to sum them at some point because we need to make sure that all of them are the same height. And the only way to find the height is by summing them through the entire array. So what I'm going to do is, instead of H1, sorry, I should have clarified just now, sum 1, sum 2, and sum 3. Oh, sorry, sum 2 is not equal to sum 3. So yeah, I first find the sum of each, what did they call it? Each stack. And then I'm comparing if the stacks are not, basically I'm making sure that the sums are not equal together. If they're not equal, if they are not all equal, then I'm going to the next step, which is to find the maximum, and I'm popping the topmost item. So how do I do this? Okay, another thing that I need to do is I need to come up with an index. So let's call it I1, I2, and I3. And I'm going to assign 0, 0, 0 for them. I1, I2, I3, as they are basically reference the index. So what's going to happen is I'm going to first find what is the highest item, like what is the max, which one of these stacks, the sum 1, sum 2, and sum 3, which one is the highest? So maxa is equal to max, sum 1, sum 2, sum 3. And I need to put this in an array. And if someone equal sign maxer, I'm basically going to minus off the first item. That means the first item over here, I'm going to minus it off from that stack. So someone is references the stack 1. And since someone is equal to the max value, I'm going to do something like someone minus H1 I1. And then I1 is going to get a progression because I don't want to do any like delete operation, because delete operation is time inefficient. That means it's efficient to pop from the back. Like if it's a pop operation, that'll be O1 time complexity. But if it's a delete operation at the front, it might not be, if you're using Python, that is. So the best way to go about it is just to keep a reference, index reference, which is what I'm doing over here. 0 references the topmost item. And if I have to delete something, if I'm removing this, this will be the next index reference. So I1 will get a promotion +1. Likewise, I'll just do this for the rest of them. Sum 2 is equal to maxer. I'll just copy paste this. Sum 2, H2, I2 gets a promotion. And else, we can assume that if it fails, if it's not this and if it's not this, it has to be sum 3. So let's do this. Sum 3, H3, I3 gets a promotion. And with that, this thing will terminate when the sums after the minusing of the topmost item, the sums will become equal. That means that's when the while condition will terminate, and that's when we know that we have our answer, so we can just return whichever one, because all three values should be the same. So I can just return someone. And let's hope I get it right. Oh, I got it wrong. Let's see. I2 is out of range. Hmm. Did I make a mistake? I1, I2, I3. I2 gets +1. So that means my terminating condition might not be what I think it is. Is that it? I see. Okay. Someone. Yep. I think this should do it. Yep. So yeah, careless mistakes happen. Forgive me for that. Anyways, this is the solution that I have for equal stacks. It's quite an interesting question because it makes you think a little bit for how do you make sure that all of them are equal. And yeah, it's otherwise a very straightforward question. Just that don't, like, when I saw this question, I was a bit wondering why it was arranged like this. Like, it wouldn't have made a difference if, like it seemed more intuitive that they would keep the item that needs to be popped at the end, but they didn't want to do that and they kept it right at the front. So don't perform like index-based popping, because that would be very time inefficient, because you're essentially have to traverse through the whole thing. And if it's like something that we need to pop from the front, it might end up costing the whole array. So in the case of like 10 to the power 5, it'll be a really, really inefficient code. So yeah, that is my solution for equal stacks. Wait, why am I celebrating slowly? I need to submit the code. Okay, I was low-key scared just now. Like, if I talk so much and then like I don't pass all the test pieces. Anyways, yep, good thing it worked out. And this is the solution for equal stacks. If you can think of a more efficient solution, do let me know. I'm quite keen on learning as well. So yep, this is my solution for time equal stacks, whereby summing operations are of O n time complexity. Each one will be O n time complexity, while the while loop operates quite efficiently as well, because we'll try to find the fastest point in which we reach the condition where all of them are equal heights. So yeah, hope you guys enjoyed the video. I'll see you guys in the next video. Thank you. Bye.